Hi, welcome to solveandgo.com. This is the next solution in a series of solutions to the MAT135 final exam from 2009. This question is about asymptotes. So let f of x equal x over e to the x minus x. Then f has how many asymptotes? Okay. Well, first of all, let's take the limit as x goes to plus or minus infinity. So we'll do plus infinity first. X goes to plus infinity, x over e to the x minus x. So what do we get here? Well, the limit of the top is infinity. What about the limit of the bottom? So the limit of e to the x minus x. Well, e to the x grows faster than x, so this should really be plus infinity as well, which means we'd have to use L'Hopital's rule. What I'm going to do is I'm going to do the usual thing you would do with rational functions, so the quotient of polynomials, and I'm going to divide the top and the bottom by the highest power of x. Okay, so sometimes that will help. So we get x over x on top, and e to the x over x minus x over x on bottom, which is the limit as x goes to infinity of 1 divided by e to the x over x minus 1. Okay, so now we have 1 over e to the x over x minus 1. So let's see here. E to the x over x, what's its limit? As x goes to infinity. Well, plugging in infinity, or taking x as x goes to infinity, we get an indeterminate form, infinity over infinity. So we can use L'Hopital's rule here. Okay, so I'm going to put this up here. So using L'Hopital's rule, the limit as x goes to infinity of e to the x over x is the limit as x goes to infinity of e to the x, that's the derivative of the top, divided by 1, which equals plus infinity. So the limit as x goes to infinity of x over e to the x minus x is, so we rewrote this. This is going to be 1 over e to the x over x minus 1. And we know e to the x over x goes to infinity. So this is 1 over infinity. This is 0. Okay, so we have one horizontal asymptote. As x goes to infinity, this function goes to 0. Okay, so we'll rewrite things in the same way to take x as x goes to minus infinity. So we have the limit as x goes to infinity of x over e to the x minus x. We're going to rewrite this as the limit as x goes to, so we're going to take, we just took plus infinity, let's take minus infinity. So minus infinity. So this is 1 over e to the x over x minus 1. So now we need the limit as e to the x over x goes to minus infinity. So the limit as x goes to minus infinity of e to the x over x is, well, e to the x as x goes to minus infinity goes to 0. X goes to minus infinity, so we get 0 over minus infinity in some sense, which is 0. So, in our original limit, we get the limit as x goes to negative infinity of x over e to the x minus x is the limit as x goes to infinity. Again, we rewrote this. 1 over e to the x divided by x minus 1, which is 1 over negative 1. Remember, e to the x over x went to 0, which is negative 1. So we have a second horizontal asymptote. As x goes to negative infinity, our function goes to -1. So that's 2 horizontal asymptotes. Now what about vertical asymptotes? Let's look at our function here. We have x over e to the x minus x. We'd get a vertical asymptote when possibly if e to the x minus x is 0. But there's no solutions to this equation here. Okay. E to the x is always bigger than x. Let's just take a look at the graph here. What we get, so we have this linear function here, and then e to the x grows above x. And so we see e to the x is always bigger than x, and they never intersect. So this is never 0, which means there's no vertical asymptote. Okay, so there's 2 horizontal asymptotes, one at y equals 0, one at y equals -1, and no vertical asymptote. And that's the solution to question number 15.